Okay guys, so for today let's work on the simple 0x41hz here. And let's go and save this file. Let me just transfer it. Okay, so if we try to ls, we now have the file here. And some of the things that we can try to do here is to first try to check for strings. And you will see that there's this function here, or some text here that signifies it's just a simple binary. Tell me the password, is it correct? I don't think so. Nope. Well done. And of course we can go and try to check what the file is all about, or the version, and we can see here that this is an unknown arc ELF64-bit MSB, so we can try to copy that, and then we can try to go search it here. And you would see that there's this assignment number bonus obfuscated shellcode and unique trick. And if we try to go down here, this blog post has been created for completing the requirements for the Security Tube Linux Assembly Expert Certification. And if we try to go down here, we have an obfuscated shellcode. It will be using some obfuscation techniques like MMX instruction, disalign opcodes, addition to hide real values, stack to store data instead of data segments. And if we try to go and check out XDD 0x XXD 0x, we can see here that we do have some hexed here, or let's say if we go and hex editor 0x, we can see that we have here the ELF, and we have 02 here, 1 2 3 4 5 6. And if we go to the documentation here, we can see here there's this unique trick. Second is a technique I found myself as I was working on the Linux ELF format. I noticed that it's possible to change some bytes in the ELF file header without altering the normal execution of the program. For instance, you can persuade your executable is 32 bits even if in reality it's a 64 bits one. You can also indicate your binary is made for a big endian platform even if in reality it's not true. This technique may be useful again in reverse engineering. In order to alterate the header, you can use any hexadecimal editor like hexcurse, and we have the 5th byte defines format for 32 bits and 64 bits for 2. The 6th byte defines endianest LSB1 and MSB1. So we can see here that we have 1 2 3 4 5 6. So supposedly there should be an MSB1 here, because if we try to exit here, if you remember, we do have here, let's see, in the file 0x, it's an MSB, but it's a 64-bit here. However, based from the information that we've got, MSB1, and you would see here that here in this example there's that 01 instead of 02. And so if we try to go and run this with R2 0x and analyze this, let's see, or PDF main, nothing's happening. So if we try to go and hex editor and turn this into 1, let's just say we go and translate this to 1. Let's first select it. And let's save this. Let's just see if this will work. And if we try to go and try to do this one more time and analyze it, PDF main, now we are able to access the main function here. And let's use the flag or the S main here. or est main pdf main. We use the s main, and we can see here that this is the information that we need to go and do here. We have tell me the password, and we have some move abs, move keyword, move d word, and move word. So we have here this, this, and this. So if we go get and open a text editor, let's go get this information here, paste that, and this one, paste that again. Let's also get this letter L, paste that again here, and let's go put that in our hint here and submit, and there we go. We have our streak here. Or we have our answer to this simple reversing challenge.